Okay, so great start. Thank you. We did not get through everything in the first one, so I think I'm going to skip a couple sections intentionally for this, which is fine. But all the report, or the slides and everything will be linked online. So yeah, this is about Koha reports. And I'm going to record this also and post it probably, and hopefully we'll go with this one and not the last one, because like several of my slides were just wrong, like I had a typo or something, but I fixed all of those, so this time it's going to be so much better. This is the outline of what we're going to talk about. So we're going to talk about SQL, which is the language that the reports are written in, how the Koha database is structured, so how you know what you're looking for, the basic elements of SQL, which are select, from, and where are kind of your bread and butter that you're almost always going to use. And then a more sophisticated but super important part is join, which is how you join different pieces of the database together and get like information from varying quarters, basically. We'll probably skip the parameters piece, which is how you can do like date pickers and drop downs and stuff. Nancy's really good at that, actually. If you do have questions about it, has learned most of the stuff. We'll talk about querying MARC fields, because I do want to get to that, so that's why we skip parameters. And then the other stuff is just kind of like fancy added extras, so I'm not going to cover that either, likely, but it'll be there in the slides if you need to go and reference them. I'm not going to talk about the guided reports, because you can mostly figure that out on your own, and this is really more for like the advanced usage. And the power really lies in these SQL reports, the raw reports that you can do.
Was that report that Nancy did for holds, was that a guided report, or?
That was definitely a SQL report and just would not be possible in guided reports, for instance, because I had to work with her on that pretty extensively to do a lot of really advanced things to get the sort of data that we needed. So there will be like links discussed and stuff, and links in the slides themselves, but please don't feel like you have to write them down or anything, because you can just go to this URL afterwards, and this will be the slides, and you can click on everything and go to it there. So I'd rather have us like kind of walk through things and follow along on the screen than you needing to be writing down URLs, because that's gross. And there's also in the reports module in Koha now, there is a reports workshop tab. And this has all the different little examples that I'm using in my slides. So if you ever were thinking, oh, like I need to remember how this thing was done, one of these is private. Fix that. You can always just refer to it here. I think this might be like the very first one we used. There. Okay. So the first section is SQL, which stands for Structured Query Language. And it's a very old, historic, just way of getting information out of databases, basically. And reports are this just very raw, like read-only access to the Koha database. And that's important because you can't change anything with them, right? So never worry about editing the database. And you can get any piece of information that's in there. So anything you see anywhere on a Koha page, we can somehow get to that in the database, okay? We could like create a realistic simulation of the catalog in a report if we really wanted to. That's how powerful this is. It is worth noting that it's a MySQL database, just in case you do some Googling and you come across things. There are many flavors of SQL. So for instance, like Microsoft has their own flavor that's just a little bit different and things won't be quite the same. So oftentimes that can help if you're really deep in the weeds, if you start Googling for MySQL instead of SQL. And what's really nice about this being like an existing well-known language is that there's tons of tutorials online that teach you how to do SQL specifically, and you can just use those instead of needing to learn something that's like super specific to the software. So I've linked up a few right there. W3 Schools has really good just like single pages on different pieces and different bits of syntax, like all the bits we'll cover in the next section, for instance. Hello. Oh, that's right. Joseph's going to be here. I'd forgotten.
Yeah, we walked right past it.
Okay.
Yeah, these are little weird little rooms if you haven't been in one yet. So, SQL is code. It's like computer code, but it's very simple because there's only a few fundamental building blocks of it. And just as convention, what I'll be doing is like capitalizing the code bits, the bits of SQL in there. And then everything else is going to be like the name of a field in the database, or some like piece of math, or text strings that are wrapped in quotes and stuff like that. So you don't have to do that, but it really helps to visualize things and understand what's going on. The bad part about it being code is that, of course, it's very, very pedantic. So every single like quote, period, comma, whether something is a single quote or a double quote, all of those matter. And if you get one little piece wrong, it just dies. It doesn't work. Koha breaks, explodes in a fire, and I rage quit my job. Also, the error messages are not super informative, because usually when you make some kind of syntax error like that, it just causes the report to completely collapse. It doesn't understand what's happening. It'll spit back something, but it can't really identify where you went wrong. And so really when you get something wrong, probably what you just need to do is go over your syntax very carefully. So look for all those matching things. Do I have like a parenthesis that isn't matched somewhere? Do I have a period in the wrong place, etc.? And then also make sure like logically your report makes sense. And as we go into like database theory and SQL, that will be easier for you to deduce. A really helpful approach is to write down in plain English, but very specific English, what you want in the first place. And just to give an example of how to do that, a bad like report would be, I want late books, because it's just very conceptually confused in a couple ways. Like, first of all, what late means is actually a very kind of ambiguous term. And then even what a book is kind of strange too. So are you talking about like a MARC record, a bibliographic record describing a book? Or are you talking about like the physical item out of the shelf? Because to the Koha database, those are two entirely different things. And you don't have to always connect them and always be talking about them at the same time. So a good way of articulating sort of that same thought, but much more specifically, is I want the call numbers and barcodes of items whose date due is before the present date. And so I kind of italicize the bits of lingo there that are coming right out of the database, and it makes it much easier to see, all right, these are the fields I want to pull back. That's the call numbers and barcodes. Items is the type of thing, so that's how Koha defines like a thing on the shelf, as opposed to a bib record, which is called biblio, right? So those are different parts of the database. And then date due is like the field I'm going to use to determine whether or not I want to see a particular database record, right? That's what I'm going to filter on, is I'm going to, and then this is like a really clean way of wording it, right? Date due before the present date, that's like the definition of late, for instance. So that's just immensely helpful if you can just kind of think slowly and write it out first, and then try to translate it into SQL is the best way to go about things. A lot of people have already discovered that linked inside the reports module is a wiki page, a Koha wiki page that has examples of existing reports. They'll rarely do exactly what you want to do, but they'll often be close enough that you can copy it and edit from there. Or what's even better is you can just pick up some tips or mimic some of the things that are going on in other reports. So for instance, a lot of the stuff I talk about in this presentation is covered on that wiki page, like how to get different pieces of MARC data. So that is pretty in detail and is a good place to go just for learning in general about reports. Okay, so the other thing that you need to know is, what does the Koha database look like? How do we find out what we're looking for when we write a report? And that's also linked in the reports module. So there's basically just those two links, and they're super, super useful. It's this schema.kohacommunity.org. And then it shows us all sorts of different important things, and we'll learn how to kind of read and interpret it in a little bit. But these are the sorts of questions we can answer by looking at the schema. What fields are in a particular database table? So for instance, that items field, right, that has barcode in it, that has location, home branch. Those are things that are in the items database table. What data type is a particular field? So that's really important because it affects the kind of things you can do. So there are dates, like date due is a date. That's a specific type of data. There's text, which is also referred to as varchar, which I realize looks really weird, but that's variable characters. It's just a truncated form. So think of it as like, it can be letters or numbers or punctuation. So that's why they call it varchar. But that means text. When you see that, just think text. Integer is also really common. So there are lots of identifiers in the database, and those are often integers. Biblio number is kind of the canonical one that we use an awful lot. Yeah, and so that leads into the next part, which is what is the key or identifier for a table. So the sort of principle of database theory is that everything has an identifier in there. So every item, there's going to be item 1, item 2, item 3, and there's no overlap between those. You know, those are unique identifiers for everything. And the database lingo is key for whatever reason. That's what those are called. And then how are the different database tables connected? And that actually ties back to the identifiers. So that's the way that, like for instance, a bib record knows what items it has, is because there's a connection where there's identifiers that point back to the bib record in the item records themselves. So that's something that you can easily see when you go and look at the schema. So this is an example. I kind of cleaned out some of the relevant information. But this is an example of something you would see in a schema page, all right? So you go to the schema and it's a list of like 1 million tables, and this is one of them. And I'll just walk through sort of all those different elements I just talked about, how you know they're there. So we have our identifier, and you can tell right away, it has a dark green background, and it has the ID in it. That's a good hint. And primary key is database lingo for identifier. So that's what that means. But then we see all sorts of other things. So we have a date in here. That's a reserved date is a date type. We have some integers, biblio number, borrower number. These are connections to other database tables. So you can tell because it says parents, borrowers, parents, biblio, but also the way that it's written here in the description. Foreign key means it's an identifier, it's a key, but from another database table. Okay, and so that's how these things are linked and how we'll later be able to join tables together. So this is a borrower identifier, this is a biblio identifier, we have an item identifier down here, all sorts of identifiers in this table, because it's linking together many different types of data, actually. We have a reserve notes of a text field in there as well. This is something you'll often see, so this found is interesting. A 1-letter code defining what the status of the hold is after it's been confirmed. So that's much like we saw a lot in Millennium. There's oftentimes these like P codes or whatever that have like, when you look at the actual data, sadly it's not informative. It's like 0 or A, and you're like, that doesn't mean anything to me. But what that translates to is often something useful. And if you're struggling with codes, which can be one of the trickiest parts, I'll show you a technique later for figuring out what they mean. And you can also just ask like Terry or myself to send you what our codes mean. A lot of them are defined in this authorized values section of Koha, where, for instance, like a really common one is locations. All the locations are codes. They're actually pretty readable ones, like all caps archive is a location. You'll see that and you know what it means, but it is a code. So we can let you know what some of those things are. But like a better example is like the lost field on an item is like 0 or 1 or 2, and those all have different meanings. Like one of them means lost, one of them means long overdue lost. And without knowing what the numbers map to, it's really difficult to interpret. Yes?
So where do we find it in equation 2?
I'll show you later how to figure it out on your own, but basically there's no way for you to know. You would have to ask Terry or myself. But the trick that I'm going to show you is look at a report and then look at an item in Koha. And like,
I didn't even think
right, exactly. So if you have a missing item, you can just say, all right, I'm going to look at this item's database record. And it will be like missing value 1. And you're like, oh, okay, so that's what that means. 1 means it's missing. So, and we've had to do some things like that, for instance, in like the serials reports where like claimed and other like different statuses were attached to a serial. We had to kind of reverse engineer what a bunch of numbers meant. What is this database table, by the way? What in our lives does this represent?
reserve.
You would think so. Nope. Gotcha. Yeah, it's holds. I got you with my trick table. So
Wait a minute.
this is holds.
Oh,
This every entry in this represents a hold, and it's named reserves, which is confusing, but that's what it means. Course reserves is course underscore reserves actually, and so to explain further like what's going on, right? Like each reserve has its own identifier, but then like it's placed by a patron. This is the patron. It can be. This could actually be blank. It doesn't have to be a bib level hold, but if it's a bib level hold, you'll have a bib ID in here. If it's an item level hold, you'll have an item ID in here. This is interesting too, this branch code, right? It's the foreign key from the branches table defining which branch the patron wishes to pick the hold up at. So it's not the branch that the book is located at, it's the branch where they want to pick it up at. If you wanted to figure out where the item where the item lived, where its home branch was, you would have to connect to the items table and get it in there, because that data does not actually exist in the reserve table, for instance. So, yep, it is a hold. And just to real briefly look at schema, this is what the website looks like. It's just this huge list of tables, and then when you click on one, you learn more about it. So here's Biblio, for instance. And I kind of, in my other slide, I deleted some of these columns that are not informative, but this tells you about the Biblio table, which is actually a pretty small table that doesn't have like a ton of data in it, but it has this Biblio number, which is a really pivotal identifier throughout the database. So there are lots of tables like you saw on that index page, but these are sort of the important ones that almost everything happens in. So there's Biblio. That is it represents kind of your main bib record. It has that main ID Biblio number. There's Biblio items, which this is probably the hardest one conceptually to know because I can't tell you what it's supposed to represent. It's this weird gray area in between bib record and item, but it is important because it has one field that holds the entirety of the MARC record. Okay, so if there's anything you need to know about Biblio items, it's that is where your MARC record is. And anything in the MARC record can be extracted as long as you can get to that Biblio items table. There's items, so that represents like the stuff on the shelf. So you're gonna have like, you'll have a item call number field, you have a barcode field. You're not gonna have like title or author, because those are bib records fields, right?
Those are
Items.
item record. Wait, so the Biblio record is just pretty much the number, right? And then the MARC is the Biblio.
It has a few other things, but honestly, it's not really possible to conceptually understand what the difference between the two is, as far as I can tell. But like if we look at Biblio, this is what we have.
Right.
Biblio number, author, title, uniform title, notes. Those are extracted from the MARC record, correct? Yep, all these things. And then the nice thing about this schema too is like the URL structure is really predictable, so I can find the URL. If I know the title name really easily, you just change whatever the .html is here. So this is Biblio items, and it's basically just like a more verbose version of Biblio. Like you get more data. So now we have like pages, notes, size, publisher year, etc. And then, I mean, the real important stuff though is you get total issues. So that's the total number of times something's been checked out. That's pretty interesting, pretty important. Then you get this MARC XML field, which is the entire MARC record dropped into this one big long text field. But we'll discuss that more later. So yeah, biblio-items is like this. Oh, I'm spoiling the end there. Biblio-items is like this halfway point. Full MARC record, that's important. Items represent stuff on the shelf, but it doesn't have bin info. Issues means checked out items. So that's another like linguistic difference. Remember, this was developed in New Zealand, so some of the English is like British English a little bit. Borrowers, that means patrons. Like we would definitely call that patrons, right? But they call it borrowers. Reserves is holds, as we just learned. A few other ones that are useful, like course reserves has its own set of tables. There's a table for courses, there's a table for instructors, that's in there. Old issues is previous checkouts, historical checkouts that used to happen. Historical in Koha. So things that happened in Millennium won't be in the old issues table, but that does exist. It's pretty useful. Serials and subscriptions also has a little set of tables in there. So the conceptual difference here is subscription is like the Atlantic, and it has this like pattern attached to it, right? Of we get one on the first of the month, every month or whatever. And then serial itself is more like June 2016, the Atlantic, right? It's a specific issue of that serial, and it gets attached to an item from there, right? Which is the actual piece that we have out on the shelf. Does that make sense?
Yes.
Kind of.
So in serials, you have the serial, and you have the subscription, and then you have the bid.
Mhm.
Is that right? So
That's correct.
And
And those are all connected in some way, but there are pieces of information that don't, that only live in the different tables, right? So if you wanted to see like, I want to see the subscription pattern and the call number of the most recent issue and the title or something, you're probably pulling from at least 3 or 4 different tables to get all those different pieces of info. Yeah, but they are all connected. Yeah, and so then what you already saw was, all right, so there's hundreds of tables. Is there any piece of information that somebody's interested in and you can't tell where it would fit in that small list I gave you? Like you're thinking about something and you're like, yeah, but I don't understand where that would be. Anything off the top of your head? Well, if something comes up later, ask me and we can just either I'll know or we'll do a little investigation work and we'll poke around in the schema. But yeah, oftentimes it just takes a little bit of trial and error to figure out where information lives. So that was the schema and learning sort of how it's structured and stuff. Let's do actual SQL queries with like kind of the fundamental elements, which is select, from, where. Those are the 3 base elements. It looks like this. This is kind of your standard report. So it'll be select which database fields, from which tables, where, and then you apply some kind of condition. Because usually you don't want to pull back just all the records. You only want to look at certain types of records. So that's where you can kind of filter things a little bit with a condition. So select. What do you want returned? Select is followed by a comma-separated list of database fields. So database field is like anything you see on that schema page, right? We saw reserve underscore ID, biblio number, etc. Those are the things you would put after here. So here's an example. Select biblio number, comma, title, comma, author. So that'll pull those 3 fields back. From, this is the easiest one. You just do a single database table, just one database table. And we'll learn how to get data from multiple tables in the next section. So from biblio, pretty easy. And those 3 fields that I just listed are in the biblio table, right? Otherwise, you get an error because it's like, I can't find this field, it's not in there. And then finally, where, it is optional. If you want to pull all the records, you don't have to do a where condition. For instance, if you want to see like all of the holds, that makes sense to me. That might be a thing you wanted to do. But here's a little bit of a filter. Where date created equals current date. And this, it looks funny, the current date part, because it's a SQL function. It's like a special way of always referring to the current date. If you wanted to, you could just write that date out in this format. So this is like a particular standard of date format that's really good for like sorting purposes and stuff, because it goes year, month, day, and it sorts numerically and it has padded zeros and stuff. That's how you would type out a date. Just normally, current date is more robust because it's always pulling back the current date. I don't have to edit it every single day. So I think I have that report in here. Save reports. And it's probably going to pull back nothing because we don't create bib records every day. Bibs created today. Hey, yeah, so a whole bunch, actually. This is the best this example has ever gone. Usually I run it and nothing happens, but these were all bib numbers created today. And you can see how the identifiers work too. It's kind of interesting. Like it just takes the highest one and adds another one to it. So the higher identifier generally means the later on in time a record was created. Yeah, and that was that report. So that's your basic report. This is exactly what was on the slide. Where is probably the most complicated and powerful of all the basic elements, because you can do all sorts of different logical comparisons. Basically, that's what where is for. So it also ties back to the data type that you're using. It doesn't make sense, for instance, to have like one piece of text be greater than another piece of text, right? That's a numerical comparison type. So if you have a number or a date, you can do these familiar like math operators. So you have greater than or equal to, less than or equal to, equal to. The last two look funny. They both mean not equal to, all right? So if you have less than, greater than stacked together in this like key-drawn type thing, that means not equal to. Also, exclamation point in computer science often means opposite of. So you can think of that as opposite of equal. These work for dates in the way you would expect them to as well. So like one date is greater than another one if it comes after it chronologically, right? So those comparisons works for dates and numbers. For text, you can use equal or not equal to. That's perfectly fine as well. You can also do is or is not, which I find to be a little bit actually clearer because it makes it obvious that you're doing a text comparison rather than a math comparison. But what's really powerful is you can do like or not like, and then that lets you use a percentage sign as a wildcard. So for instance, that piece of text there, text with percentage sign wildcard, that would match text with wildcard with nothing in there. It would match text with crazy wildcard with the percentage sign being swapped out for crazy, right? So that's like your all operator. Yeah.
So the percentage is for a word, or is it for
anything? It could be any number of words. Text with a really crazy wildcard would also match that.
Okay. And so, but you can't do it in a word, like you can put.
No, you could. You can put it anywhere.
So you could put like LIBRAR percentage. It'll pull up library.
Exactly. Yep. Yeah. That's a good example. So Joseph used it to like stem a little bit and get a whole bunch of words that have the same root. Yep. So it's very powerful.
I find this part confusing.
Okay.
So the like, can you just explain it one more time?
So
Like the stuff, what is the percent and wildcard? What does that mean?
percent, when you put it in a like expression like this, can be replaced with anything or nothing, and it will still match. So
Okay, so the wildcard is just like whatever you want to find.
exactly.
Okay.
Yep. So say we wanted to find all books with like Agamemnon in the title. What we would do is title like open single quote, important, percent, Agamemnon percent, close single quote. All right, and that will find it would find a book that just has Agamemnon as a title because the percents match nothing. It would find something like The Trial of Agamemnon, what a douchebag. Like, you know, it would find all of those things because the wildcard matches any text you put before and after it, and it has the string Agamemnon in there.
For that, if you put it before, like, does it matter where it is before, like, or behind the word?
Well, those are two different things, so.
Wait, so you have to ask for.
So in that, so if you did percentage, Agamemnon, here.
If you did Agamemnon percent, you would be pulling only books that began with Agamemnon and then had anything. All right. Yeah. So you could search for like all books whose titles begin with the by doing the percent. But all books that contain the, you need to put the percent in the front and back.
So then, like, we can still do a report which does both of those things.
Yeah, you could do both.
And then they would be written just one after another.
I don't want to dwell on this too much, and we'll do an example. But you can combine where conditions, which is something I didn't include in here, with like and or. So you could do, like, say we wanted titles that began or ended with Agamemnon. We would do where title like Agamemnon percent or title like percent Agamemnon. Does that make sense? So it's anything that meets either condition gets pulled back. And you can also do and, but so you would say where title like percent Agamemnon percent and publication year equals 2016. So that pulls back any book from this year that has Agamemnon. The last piece here is for dates, you can do stuff between. So you can say publication year between 2014 and 2016 or something, and it would pull back like that. That's a bad example because it's a number, actually not a date, but dates have months and days. That's a different thing. But we're gonna, okay, so this is just an example of one, and then we'll write one ourselves. So this is how you would get all the call numbers for new books. Select item call number, so that's the name of a field, and we can look that up in the schema if we don't know it. From items, so that's our database table, it's gonna have it. And then we have a condition where location equals new book. Okay, so location is like the shelving location, that's the name of that field. And new book, again, this is one of those codes, so you might not know them all right off the bat, but a lot of them are really easy to guess because they're structured like this. New book means like new books shelf. That's like the label that we use for it. Yeah, so this, and when you run this report, you'll just get back a list of like 50 call numbers and nothing else. Okay, so we're gonna build a report. What we're gonna do is we're gonna get the barcode and the home library of items that have weird barcodes. So you know our barcodes start with ICAC. We want all the barcodes that aren't like that, okay? So what's the first line of this report?
The select
Mhm.
code and whatever, I don't know.
Okay, so the field is called home branch,
Okay.
but it's not and. Select barcode, error. There you go, comma. I told you, it's very pedantic, all right? If you write and there, it will just throw a fit and die. So, comma. Yep, select barcode, comma, home branch. All right, so what's our second line? From items. Yep, so the database table is named items. That is important. Some of them are plural, some of them are not. That's a really frustrating inconsistency. Technically, they should all be plural. That's the appropriate naming convention. But yep, so that was an easy one. One last line. What's the last line of this report? And this one I'll take like close points because it is a little tricky. So we want weird barcode items So where kind line, right?
Exclamation point equals, or wait, where barcode?
Yep.
Exclamation point equals one single quote, ICAC, and single quote.
So that's very close, but that will pull back everything because it's going to pull back all the ones that don't exactly have the barcode ICAC. It's going to be a like. It's going to be a not like. So this actually gets us really close, and we'll look at this and it will look wrong, and then we'll have to figure out why. Where barcode not like ICAC percent, right? So that like everything that starts with that normal looking start is going to be matched because the percent fills in for whatever random string of integers comes later, right? Yeah. So this is like a functional, useful report. But let's take a look at the results and then wonder why they seem maybe a little bit off. Okay, so there they are. And like, what strikes you just looking at that intuitively? Yeah, some of them start with ICAC. Any idea what happened there? If you look at this item record in Koha, you're going to find out that there's a space at the start. Remember we did ICAC, but we didn't put a percent at the front. It didn't match the ones that have like a space there, and then the space doesn't really show up here. It's not really visible. But we did get a whole bunch of things, like we can see exactly what went wrong with some of the other ones, right? Like missing, unavailable hyphen, ICAC, and then a whole bunch had patron barcodes by accident, PCCAC, and then some have extraneous punctuation that slipped into the front. An interesting thing happens too if we just, you would think kind of this would be enough, right? So I'm going to edit it and I'm just going to throw a percent at the front. And then run it. Oh, that actually worked beautifully. What was it that I thought would happen? Not like.
Can you try it with a space?
Huh. Well, that worked well. Yeah, I think actually the right way to do this is like, not like that and not, and barcode, you have to repeat barcode, not like space ICAC percent. So essentially this one weeds out those weird ones.
Because actually that's the better way to do it, because the asterisk one at the top wasn't on the percentage, ICAC percentage.
Right, yeah, good point, okay. Yeah. Like this got weeded out, right, by that percent. I think this one did as well, because percent matches unavailable space hyphen space, right? So we weeded out some ones that we didn't want to weed out with that. But this one still, it begins with ICAC. I bet that one has 2 spaces at the front. Is what's going on there, so that's annoying. But yeah, we made a pretty useful report with just knowing the fundamentals.
But then if you were actually going to go forward and change that, you'd actually like the column.
Yep, and what do you think you would do to make that happen? So imagine if our question was just, we want the barcode call number and home library, right? It's just another database field that we want. So you just put it in your select. Instead of select barcode home branch, you go select barcode item call number home branch with commas in there, of course. Okay. Yeah, so these are super useful strategies. What I do is I just have a never-ending query report that's private so other people can't see it. And so rather than creating like a million little test queries, I just edit the same one over and over and over again and do these sorts of queries that are really handy because they let me look at how a table looks or a single record. So let me explain that by going back here. that first one on the left, you can look at the schema to see what the fields are, but that still doesn't really give you an idea of what's there. This is nice. The select asterisk pulls back all the fields. All right, you get absolutely everything. So this gives you a preview of what the database actually looks like, which can be a lot more handy because sometimes like you're not thinking that a field will ever be blank, but it actually is blank. You're not sure what the possible codes are in some kind of coded field. This pulls back actual records. You can kind of look through them and feel them out and see if you can write the report the way that you want or it has the information that you want. And then the other thing you can do is you can look at a single record. So this is useful for figuring out those codes where like, oh, I know that this item has a particular status, is like missing or in processing or something, and I want to find out what that looks like in the database. I can just go select all the fields from blah, 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 where identifier equals the ID. So this one, what that pulls back is like a single bib record so that I can look at that bib record. That makes sense? So those are two very basic reports that are still really handy, and I use these all the time in like troubleshooting weird things that are going on.
So for the single record, you could do that one instead of the biblio number, you could do title is like, or title equals.
Absolutely, yep, that'll still pull back the full record. Yeah, so if you had a specific title you were investigating, you do where title equals, or where title like, etc., and pull back that exact one. That'll work as well. So actually, the one that I'm doing here is, Koha has this really great property where it stores a lot of deleted information. So I deleted Nina's borrower account, but if we look at the deleted borrowers table, where it stores everybody you delete, which is pretty cool, and I just said where surname equals Bailey, because I was too lazy to look up like what her barcode or ID was, and then it just tells me like, so this is an example of a borrower record in the database. And you can see that like almost everything's blank because we don't really use most of the fields, but that's handy, that's useful. I can still go through and see like useful information here. Like, so for instance, here's some like codes, right? Gone, no address is 0, lost is 0, I don't know. Does that mean the person themselves is lost? Password is hashed, that's good. That's not actually Nina's password. Yeah, so that's just a really powerful, handy technique for learning about the database. Okay, joins. This is how you get information from multiple database tables, and it's probably the hardest part conceptually. I think once you get it, it's not that bad. But it does, this is where like knowing a little bit about how databases are structured and their theory actually is necessary. So this is just like a straight up example before we talk too much about it of what it looks like. So say we want to select item call number and title. Those two fields do not live in the same database table, okay? Item call number is in the items table, title is in the biblio table. So at first glance, it appears impossible to get both at the same time. But what you can do is you still have your from line. It still only has one database table, from items. But then what you do is a join statement. So what you do is join biblio on items.biblionumber equals biblio.biblionumber. So exactly what's happening there is I'm joining to another database table, so join database table, on, and then I have to say that there's a connection between these two. I have to find a link where they share an identifier. Okay, so I'm saying for every item in the database, it's got a biblio number in there. Find that biblio number, go look in the biblio table, and combine it with the information on that same record, okay? And this is visualized in just a bit. So I think this is the easiest way to understand that. All right, we have our items table, right? It has an identifier, item number, and then it has a whole bunch of other fields, including biblio number, and like item specific sorts of information like barcodes, call numbers, whether something is lost, whether it's checked out, all that sort of stuff. Biblio table has a biblio number, that's its identifier, and then it has a whole bunch of bib fields. It has a title, it has an author, etc. And what happens when we do that join biblio on items.biblionumber equals biblio.biblionumber is it combines the two tables into one using that biblionumber as a sort of glue. So what's happened here is we now have 3 rows, but for those first 2, they had the same biblionumber. If you notice, those are 2 items on one bib, so like 2 copies of the same book, right? But it just kind of tacked onto this item number 1 now has a title and an author field, which it didn't previously. It has these bib fields attached to it. And 2 has the same thing, and then 3 got attached to a different record because its biblio number is different. So it got a different title and author in the end. Does that, at a very high level, does that make sense? How that works? Yeah. Allie's just smiling.
Yeah. It'll make sense at some point.
Okay. Yeah, so I'm gonna skip that part. I think it was bad. Let's build another report. So we're gonna do that same report, basically, but we're gonna add title to it this time. All right, we're gonna get a title in there. So just like last time, let's step through it line by line. What's the first line gonna look like?
Select barcode, comma, title, comma, home branch.
Exactly. The order is not like super important. All right, second line.
From biblio, or because you got it's from one of the tables and maybe join the other one.
Mm-hmm.
Yeah,
Yep.
matters which one you pick and then which one you join.
It happens to in this instance, actually. Actually, no, it doesn't. No, it doesn't matter. Yeah, so
So you could,
do one again.
you could select from items or biblio.
Mm-hmm. Yeah, because
And then
ultimately what does happen at the end is you get that join table, remember? So it's as if all the fields kind of exist in the same place. So it doesn't particularly matter which one you start out at because you're going to end up with one table is essentially what happens. So in this instance, I chose to start at items. So what's the next line? This is the tough one, join, right?
Biblio
Mm-hmm.
on
is it
biblio
biblio on
number.
item?
What's on this parentheses?
Parentheses, yep.
Is it biblio number equals biblio item? Those parentheses?
Pretty close. This is like a shorthand syntax that I actually decided to skip this time because it was a bad idea to teach the shorthand. But it's going to be we're gonna back up a little bit. It's going to be this, okay? And what's going on here is it's like table.field equals table.field, right? So it says in this table, where do you want me to look? Equals in this table, where do you want me to look? So that's the syntax there. So items.biblionumber equals biblio.biblionumber. Now, if that seems like silly and redundant, that's why this using syntax is nice, because it just says, hey, this exists in both tables.
I think that makes more sense.
It does. The difficulty with this is it only works if you're doing 2 tables. So I strongly recommend that people stick with on. What happens with more than 2 tables is oftentimes an identifier exists in all 3. Biblio number will be in all 3. So if you say using biblio number, the database, which is very dumb, will say, oh, but there's 3 and I can only compare 2. Which 2 do you mean? And it just dies. That error actually is informative. It says biblio number is ambiguous, is what it'll say in that instance. And that's a common sort of error you'll see where you need to specify what table a field comes from, because you have multiple of that field in your resulting table and the database got confused. So that's why we have to do items.biblionumber equals biblio.biblionumber. We have to say where in the table or in which table does the field come from.
And would you have to do it? So your biblio number has to exist in each
Yes.
table that you're looking at.
Mm-hmm. Yep. And so that's why the schema is useful. It shows you which tables connect to which tables. But oftentimes you'll be like, no, but like this must have that piece of information, right? And that usually means there's some kind of intermediary. You can almost always get where you need to go, but you have to connect to a table, and then that table connects to the table you need. So for instance, there is a weird thing where biblio items has an item. How does it work? Yeah, biblio items is a really good table. But there's just weirdness in like items connects back to both biblio and biblio number, but those two don't connect to it, for instance. I don't know if that makes any sense. But yeah, sometimes you have to kind of poke around in the schema to figure out how things go. It does visualize it too, which is pretty handy. So down here, this shows you, and it makes it so much more visceral, connections, right? So this is actually exactly what I'm talking about, how like this one connects through, but this one has no direct link to items, weirdly enough. It makes sense when you think about there are many items for one biblio. That's why that can't happen. But each item has only precisely one biblio. So it has to do with like the multiplicity, basically. But yeah, there are other ones where this is very useful, being able to see, oh, this is how the things link together. Like let's take a look at borrowers, which I bet is a crazy complex. Maybe it's not actually. Maybe it's not connected to that many things. No, it is. Oh yeah. Oh yeah. Look, so we got are connected to your message preferences, to your message queue, to old issues, right? Those are your old checkouts, to your old reserves. It's connected to your lists, your image, blah 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 blah. It's connected to like everything. Okay, so.
That's beautiful.
Yeah.
What do you mean?
Why don't you like, okay, borrow number connects to, I don't know, it's like.
Yeah. This is like an automatically generated visualization, right? So it's just having real trouble with its algorithm dealing with complexity that great. This is how I would do it, is see that children? These are all the tables it connects to. So I would look in there. This is the schema, the Koha database schema. It's linked in the reports module. So these two useful resources, they're not kidding, they are really useful. So Koha report library, Koha database schema, that is exactly what I'm looking at. Yep.
And then what's the report library?
The report library is the Koha wiki that has examples of existing reports. Well, let me go back for some reason. Oh, because it popped open in a new tab. Okay. And then, yeah, so the last line is the same as it was before. Our condition is the same, where barcode not like ICAC. But yeah, so we pulled some information from the biblio thing. And this is a really common approach, right? Like most of the time when you want data on item, it's nice to know what the title of the book is, right? It's very abstract to just see a call number. So you'll very frequently be joining things back to biblio so that you can get that title field or author field, or publication year is really useful, though I think that might be in biblio items. So you can do as many joins as you want. You just list them one after another, and it's a whole chain link fence, basically. So that's kind of what we were just seeing, where items connect to biblio, items connect to biblio. That same thing is happening here, where we wanted one additional piece of information, ISBN. Well, ISBN just happens to be one of those fields that's in biblio items, but not in biblio. So we join to biblio first, and then we join to biblio items on biblio.biblio number equals biblio items.biblio number. And that's generally how it's going to work, is like from items, join biblio. All right, now we have to use these two tables in our home. Biblio, join biblio items. Now we have to use these two tables in our home.
So then if you're
Generally, that's how it works. It's not always true, but it's a good principle.
So if you wanted to join another table, then you have to do a whole other line, patron,
Borrowers.
you know, biblio number, or, so, but it's, you can't just
Yes.
like, do join biblio on, biblio number equals, items equals something. You have to keep
Correct.
do the join.
Yep,
Okay.
every time you have to do a new join. Yep, that's
And
correct.
then join include the line top.
Yes. Yep, and then we just have our where condition in the end. And like any field from all three of these tables now, we can select or we can use in our where. Because in our results, we have all the fields across all those tables, right? So we could select any of them. We could use a where condition on any of them. Yeah, so that's joins. This is like the more complicated part of joins is there's like different types. Generally, don't worry about them. Like if this is necessary, that's where I will step in and help you. But the ones that we've been doing are this is your default standard join in the middle there. It's called an inner join. It basically just finds the connections and meshes them together. But there are weird instances where what you want to do is I want all of one table connected to another one, but if there isn't a connection, if sometimes I don't have the identifier, I still want the record on my left-hand table. So like that's a left join here. So for instance, area where we need to do that was that that improved like holds queue thing, because the way that university IDs is stored is interesting. There is no university ID field on the borrower table. Instead, it actually connects to another table that has the ID, but some people don't have IDs. So originally when we wrote the report and we just used this naive join, what it actually was pulling was not people who have like a hold or whatever. It was people who have a hold and have university IDs. If you didn't have a university ID, but you had a hold, you were in this segment and you were being left out. Yep. So those sorts of issues, like basically if you run into something where it's getting kind of conceptually hairy like that and you feel like you're missing records you should be seeing, let me know and I'll investigate, and it probably means that we just have to use one of these other joins. But the point is that it's incredibly powerful, right? Like these set of operations allow us to do any kind of combination we want. Very, very powerful. Okay, we're gonna skip parameters. How are we even doing on time? I assume we're like almost done. Yep. All right. So as with the last time, we went way long. We're gonna skip because I think MARC is more interesting and useful in general. So as I've mentioned several times, biblio items holds the entire MARC record in a single field called MARC XML. XML is a data format. It's a markup language similar to HTML. So that's where that's coming from. And basically, the full contents are in there encoded in this special XML format. The other fields that you see, like title, ISBN, author, are extracted from that MARC record. But most of the MARC record, or like many pieces of fields, aren't accessible anywhere in the database. So a really great, frustrating example of that is subtitle, right? Like subtitle is not in the database. It's in the MARC record, but it's not in the database. And we see this crop up everywhere where there'll be like some weird screen where for some reason all you see is the title. Like this occurs in subscriptions some places, I think. You just see the title, no subtitle, and it's pretty annoying. Right? That's why.
Yeah, the Earnest monitor, I was like, how do you do that? Like, can't tell.
Yep. Yes, that as well.
The MARC XML field.
You can.
Okay.
Yep. Yeah, and we'll go into that.
Is that also why when you're looking for something, it doesn't, you can't like do the, what is it, the additional like, WWD has to be typed in as limits or daily.
Maybe it's not looking at the actual typing.
Is this on like the staff side or something, or?
On the staff side.
It's possible that that search engine is implemented in a more naive way. Generally, what search engines do is much more sophisticated than a database query. So they have all sorts of special indexes, and they recognize things like abbreviations, and they pull them back. So I can't say for sure. But is that in the record anywhere? Like, is there a field that says WWD? Yeah, there's an alternate title. Okay. If there is, it should come back. But I mean, we can try it right now. Like, what does WWD pull back in the catalog? Because the catalog definitely uses a search engine.
Yeah, I feel like the catalog works, but on the stack side,
Women's Wear Daily. Yeah, so it's the very first result. So it understands that there's like an alternate title there.
Yeah, other title.
so yeah, when
It's the first result on the staff side as well.
but when I'm looking in serial,
So maybe
title,
that is like, it's basically one of those like queries probably on the title field or something. So it's not using the search engine, it's using a SQL query, and that's just much more naive. It's not going to be nearly as accurate. It's going to expect a very specific title. Yep. This is what MARC XML looks like. Okay, so this is just, the field is a big text blob. I did some color highlighting so that you can see, but to translate this into the MARC that we know and hate, it's this is a 100 tag. It has first indicator 1, second indicator blank. Subfield A is Vance, James E. Subfield 9 is 6746. Everything else there is the XML syntax, where it puts things in these data fields. It has this tag and indicator attributes. It has these subfields, etc. So, kind of what you were alluding to, you can just treat this MARC's XML field like a text field and do like a like query on it. So we could say where MARC XML like % Baltimore %. And that'll find records where Baltimore appears anywhere in the MARC record. It doesn't control what tag it's in, anywhere in the record.
Can you make it do where like a proximity thing where it's like 260?
Well, the better way to do it is this other way. Okay, so you can extract data from specific MARC fields, is the important thing. So basically, this is just, it's unfortunately another piece of syntax you have to memorize. It's this extract value function, and the way it works is you go extract value, open paren, MARC XML, comma, then you do what's called an XPath expression, which I'll explain in a little bit, and then close paren. So for instance, say we want to get the A subfield of 490. That's what it looks like, right? We have our 490 field, we got our indicators. We want just the CCA part, okay? Just the CCA. This is what we would write. Extract value, open paren, MARC XML, comma, and then, so very important, again, like there's a lot of punctuation here. It all has to be exactly right. Open single quote, / data field, open rectangle bracket, at tag equals, double quote 490, close double quote, close bracket, / subfield, brackets around at code equals A, blah, blah, blah. All right, so that's a lot. That's a lot, but only 2 pieces of it ever change, right? All you really need to know is you copy paste this whole bunch of crap and change these 2 pieces. You change what your MARC number is that you want, and you change what your subfield code is. That's all. So what would we do to get the subtitle, that elusive subtitle?
245, the MARC field number, subfield code B.
Exactly. We did it. We got the subfield, the subtitle. It's amazing. Yeah, so you would put 245 in the at tag, and the at code would be B. This is how you would get 360C, for instance. So data field at tag 360 / subfield at code C. Just to understand conceptually what's happening, you could read this expression as, hey, start at the root of the document. That's what the / is, and it's why it has to be at the beginning. Find the data field element where tag equals 360. Inside of that, so the / is always inside, we're drilling deeper into the document. Inside of that, find the subfield element where code equals C. Inside that, return the remaining text content. And that's kind of what always happens at the end is give me the text. That's always the outcome at the end. It's probably handy to know if you want just a whole MARC tag, you're not interested in a subfield, you just leave off the brackets at code, but you do keep the subfield. So this gives you the whole responsibility statement, the whole 245. / data field, brackets around that tag equals 245, and then / subfield. That kind of roughly translates to give me all the subfields combined, is basically what that means. So that'll get you that whole 245, which can be really handy. And I mean, that's probably a more useful label a lot of the times than getting the title or the author, right? It's like, let's just see the whole 245 field all at once. You can do this extract value thing in select or where. So explaining the two differences here. On the left-hand side, we are pulling the subtitle field out of all records that have a title that begins with birds. Okay, so that's what's happening. We're connected from the biblio items to the biblio, and we're filtering on the title like birds %, right? But ultimately what we're pulling back is the subtitle. On the right-hand side, on the other hand, we're selecting the title, so we are grabbing that title database field, but we're filtering on subtitles that start with birds. Does that make sense? So you can both use MARC fields to filter, or you can return MARC fields. Yeah. And I think that's it. Yay! That's all the extra stuff that we don't need to do, but we're definitely at our hour. Does anybody have any questions? I threw an awful lot of information at you, but this will be recorded and I will give the slides. Yep. Yeah, for sure. So I think you missed at the start. They're already up at this URL, and I'll chat that in Slack now that everybody's been to one of the report sessions. I may do a Redux one because we did have a few people, including Lisa, who missed them. And I think the recording of this session is probably the recording that I'll use, just because I had some errors in my slides in the first one. Yeah. Anything else? I hope that was vaguely useful. And
More useful than the bywater.
Good. And I did want to say the motto is go out there and try to get things done. But like if you get stuck, absolutely ask me. I realize a lot of this is really complicated, and you're definitely not going to absorb it right the first time away. Also, like other people have become quite good at reports as well. Like I said, Nancy's really jumped in. Janine's understands it pretty well as well, and she was in the last workshop. So.
Yeah.
Excellent. Okay.